is still concerned about the application of force, mass, and also accelerations. Let me share with you the related slide. So can you see this slide? Class. So this one is you can solve about the example two, but before that we have let's have a look on this problem one. So the problem one is concerned about the let's have a look on this problem one. The question is the crane lifts a crate of mass m with an initial accelerations a. So in this case, the acceleration is equal to 3 meter per second square. Determine the force in each of the supporting cables due to these motions. So they ask you to find out what is the force in each of supporting cable. So we have the supporting cable of A, B, and also CB. So you need to find out. So the answer is given, which is equal to 5.60 kilonewton approximately. So we try, let's do this, so called what is the solution of this problem one. Let me add a blank slide. So of course, when we deal with this kind of problem, in many problems, the first step is you need to draw the free body diagram. You need to draw the free body diagram as the initial step. You need to jot down all of the related data which is given in these questions. So the solutions. Problem one. Draw free body diagram as usual. So we have the crate. So we have the crate. So I have no on this. Okay, ABC. ABC, the grade. The supporting cable is AB and also BC. We have this A, B, C. And it's given that the mass of this crate is equal to 700 kilogram. So we consider this it is the center of mass. So the value is equal to mg, which is equal to 700. You need to multiply with 9.81. So that one is equal to 6867. 6867 Newton for this W. So they ask you to find out what is the force in each supporting cable. It means that we have this supporting cable of AB and also BC. So we can also draw the free body diagram simply like this. And it is given that the acceleration is equal to 3 meters per second square. 3 meters per second square upward at this instant shows. So the supporting cable is we have this AB and also BC. Let's consider this one is as T, TBC and also TAB. This one is A, this one is C. So what is the supporting cable? Force of in each supporting cable of TAB and also TBC. So you need to find out this. And it is given that the angle is 345, and this one is BC. B is 3, C is equal to 4. 3, 4. Of course, this hypotenuse is equal to 5, similarly to this one. 3, 4, 5. BC. B is equal to 3, C is equal to 4. So you need to jot down and you need to illustrate all this kind of thing to simplify and also to facilitate your method of solution by illustrating all of these forces which act on this grade. So if you look at this one, so it shows that TAB is equal to TBC. TAB is equal to TBC. And of course, through these illustrations, we can we need to apply the appropriate mathematical functions such as the trigonometry identities in solving this problem. Let's say for this at point A and also point C. So we have this kind of thing. And we can also put this over of that is as equal to TB. So TAB is equal to TBC is equal to TB. We can simply put like this. So in each of these, we have this theta. So we can actually split into the component of x and also y on for each of these. So this one is A, this one is B. Each of these we can split into the component of x and also y to simplify or to facilitate our analysis. So we're going to have the component of this one is t. Since we are using this tb on all both of these, and we can put it as a tbx, and tbx is equal to tb cos theta, and for this one tby is equal to tb sin theta, similarly to this one, this one. So tbx is equal to tb cos theta, and this one is tby is equal to tb sin theta. And we know that when we look at this, we have this, let's say, 3, 4, 5. This one is theta, right? And therefore, cos theta is equal to 3/5. Sin theta is equal to 4/5, right? When we look at this illustration, we need to apply the trigonometry functions in solving this. So we're gonna have this if we substitute into these equations. So this tbx is equal to tb cos theta is equal to, you need to multiply with 3/5, and for this one tby is equal to tb multiply 4/5. Similarly to this side, it is on the left and also right side of this. So we're gonna have this tb 3/5 for this tbx, and tby is equal to tb multiplied with 4/5. Okay. So once we illustrate all these kind of thing, we can go to the next step. Is so that is the first step is draw the free body diagram. So the second step is equation of motions. Equations of motions. Applying the basic equation of motions, the sum of fx is equal to max and sum of fy is equal to may. Sum of f x equal to max, positive to the right word for this x. Sum of fy is equal to may, positive upward. Let's consider this one is first equation, and the sum of fy is the second equation, equation of motion. Applying the basic Newton law of motions. Let's consider on this sum of fx is equal to max, positive to the right word. Is there any acceleration in the right word? No acceleration at all, because only what's so called a vertical acceleration, the grid is lift upward, and the acceleration of a, which is equal to 3 meters per second square. And therefore we can consider on all of the forces in the x directions by looking at this looking on this what so-called illustrations or the three body diagram, the previous one. So sum of Fx is equal to MAx, any forces in the x directions, which is TB multiply with 3/5 minus TB 3/5 is equal to mass is equal to 700 multiplied with AX, where AX is equal to 0 meter per second square. So we can put it as 0. And therefore, TB 3/5 minus TB, this one we got this 0 is equal to 0, and both of that is 0. So this is the forces in the x direction, which is equal to 0, and no forces in these directions. And then go to the next step, considering on these y directions. Sum of Fy is equal to MAY. So substitute whatever the forces in the y directions. So we have this TBY at point A and also at point B. We have this TBY. Both of that is equal. TB multiplied with 4/5. Then what we need to do is just substitute into these equations. So TB multiply with 4/5 plus we have another one. TB multiply with 4/5. What else? We have W is equal to 6867. W, which is equal to 6867 Newton, directed downward. We need to minus this W, 6867 Newton. What else? Forces which need to be considered. No forces, no other forces. Okay. So only three, which is TB 4/5 plus TB 4/5 at point A and also at point C, minus W, which is equal to 6867 is equal to, what is the mass? Mass is equal to 700 kilogram. AY is equal to 3 meter per second. So by solving this one, 8/5 TB minus 6867 is equal to 2100. And therefore, when we solve this one, we can get this TB is equal to 5604.38 Newton. That one is approximately 5.6 kilo Newton. So we got the answer already. So that is step or method of solutions for this problem 1. Is there any question before we continue with the example 2? Okay, class, is it okay?
Yes, sir.
Right, we continue on next, which is concerned about example 2. Still concerned about the application of force, mass, and also accelerations. So the question is, the baggage truck A has a weight of 3,600 Newton and tows a 2,200 Newton, 2,200 Newton cuts B and a 1,300 Newton cut C. For a short time, the driving frictional force developed and the wheels is Fa is equal to 160 T, where the unit is in Newton, and T is in second. If the truck starts from rest, A determines its speed in 2 seconds. So it starts from rest. And B, what is the horizontal force acting on the coupling between the truck and cart B? Let me add a few blank slightly. So they ask you to find out what is its speed in 2 seconds, where it start from right side. This car, this baggage truck A, which tows two cart, which is cart B and also cart C. Here is the illustrations, and if you look at this one, of course, as usual, the initial step is you need to come up with this free body diagram. So from this free body diagram, we need to consider all of this weight. When weight of this truck A is equal to 3,600 Newton, cut B is equal to 2,200 Newton, and cut C is equal to 1,300 Newton. So NA, NB, and C is actually represent on the normal force on each of these truck A, cut B, and also cut C respectively. FA is a frictional driving force. The frictional driving force, where the frictional driving force, they give it in form of force as a function of time t, which is FA is equal to 1/6, and that's why. A, so FA is equal to 160T, where the unit is in Newton. The frictional driving force is to the left or to the right, to the leftward. If you look at this illustration, so this is the free body diagram. So of course, you need to come up with this free body diagram showing all of the forces which act on this truck A and also cut B and cut C respectively. So we have to consider all three vehicles all together, which is truck A, cut B, and also cut C. So that is the first step. The first step is free body diagram. Step 1. So what is step 2? So once you draw the free body diagram showing all of the forces which act on this, in this case, truck A, cut B, and also cut C. So the second step is what is the equation of motion? So step is step 1. A. Step B ataupun step 2 lah. Step 2 is equation of motions. So equation of motion. So it shows that this truck A move to the leftward. So we can use the what so-called positive sign conventions to the leftward as a positive. Let's say equation of motions, sum of F x is equal to MAX is positive to the leftward. It's our reference actually. And we have another one is sum of Fy is equal to MAY. So we are applying the Newton law of motion, basic equation for the Newton law of motions. That's equation 1 and also equation 2. Let's consider on the first one. Sum of F x is equal to M A X positive to the leftward. So in this case, if you look at these illustrations, what is sum of fx? So we only have this driving frictional force of Fa. Fa is equal to 160 T. So we can write down the equations of Fa, what else? No, only one. Fa is equal to M. M represent on the total mass of this one is MA plus MB plus MC. We can put it here MA plus MB plus MC divided by 9.81 because they give you in form of weight in Newton. So in order to find out mass, you know that W is equal to mg, M is equal to W divided by G. G is equal to 9.81. Multiply with AX. AX. Where in this case, AX is equal to, we can consider as A acceleration to the leftward. Right? FA is equal to 160T MA 3600 plus 2200 plus 1300 divided by 9.81 multiply with AX equal to A. So if we simplify this, we can get the equation of A is equal to 0.221 T. If we consider the sum of Fy is equal to MAY as a second equation, then if we once we got this, we can put it as equation 3. Equation 3. So they give you in form of acceleration as a function of t. Acceleration as a function of t. So since they give you in form of a as a function of t, they ask you to find out what is the velocity, right? The velocity. And we know that based on the previous one that you learned in chapter 2, we have a variable kinematic equation of motions. Which is we know that A is equal to dv over dt. Variable kinematic equation of motion. So it's related with the acceleration of A, velocity of V, and also time t, right? For these equations. So in this case, we need to rewrite these equations. Based on this equation, A is equal to dv over dt. Let's consider this as equation 4. So dv is equal to A dt. So we need to apply this since they give you in form of A as a function of t. So we need to, in order to find out the or to calculate the velocity, we need to apply the integration of both of this side, which is dv should be not up to v is equal to A d not up to the A dt. And this one is equal to You know that A is equal to 0.221 t. So what we need to do is substitute A into this equation. So it's become 0.221 t. So if we simplify this, V minus V naught is equal to 0.221 t to the 2 divided by 2 between t naught up to t. So if we simplify this, V minus V naught is equal to 0.1105 t to the 2, where t naught is equal to 0 second. So V naught is equal to 0 and V naught is equal to 0 meter per second, because it starts from rest, and therefore we can get the equation of V is equal to 0.1105 t to the 2. So when t is equal to 2 seconds, what is the velocity? So let's consider this as equation 5 for this one. When t is equal to 2 seconds, therefore V is equal to 0.1105. We multiply with this 2 power 2, then we got the answer for this velocity when t is equal to 2 seconds, which is 0.442 meter per second. Okay. Let's say they ask you to find out what is the distance when t is equal to 2 seconds. This one is considered as an additional question. What is the distance traveled when t is equal to 2 seconds? So, or find the distance s when t is equal to 2 seconds. So what you need to do is, we have the equation for this v is as a function of t, right? So we know that v is equal to ds over dt. This one is also considered as a variable kinematic equation as well. So we rewrite this equation and rewrite it. So it's related with this v, it's related with v, s, and also t. So we can find out what is the distance s. So ds is equal to v dt, and therefore ds s naught up to s is equal to v dt from t naught up to t, where s naught is equal to 0 because it starts from rest, and t naught is equal to 0 second. So what we need to do is substitute equation 5 into this equation. Substitute equation 5 into the above equations. So if we integrate this, we can get this s minus s naught is equal to equation 5. Is equal to 0.1105 t to the 2. 0.1105 t to the 2 time dt between t naught up to t So what you need to do is just applying the integrations. Let me add blank slide again. So we can get this S minus S naught is equal to 0.5505 T to the 3 divided by 3 between the T naught up to T. So what we can get from here, S naught is equal to 0, and similarly to this T naught is equal to 0 as well. Therefore, S is equal to 0.1105 divided by 3. We got this 0.0368 3 T to the 3. And when T is equal to 2 seconds, just substitute into these equations. 2 to the 3. So when you solve this one, you can get the answer for this S, the distance of S. What is the distance of S? Try to calculate this one. You'll got the answer of 0.2944 meter. Try to calculate this one by your own. Correct or not? So that is an additional question that I gave to you. And let's say they ask you to find out what is the distance S when T is equal to 2 seconds. If they ask you to find out what is the distance S when T is equal to 10 seconds, for example, you can also use the same step in solving this to get the answer for this one. So step 2, equation of motion. Okay, you got the answer for this V. So we have another one question for this one. They ask you to find out what is the horizontal force acting on the coupling between the truck and cut B at this instant. Question B. Question B. This one is considered as question A. The horizontal force. What is the horizontal force acting on the coupling between the truck and cut B at this instant? So of course you need to come up with this free body diagram again. They ask you to find out what is the coupling force. Let's say you consider as T. Coupling force T. Let's say we consider this truck A. So truck A, it has weight of 3,600 Newton, and A represent on the normal force, and you know that this FA is equal to 160 T, the driving frictional force, and this one is T, the coupling force T. So this is the one that you need to find out what is T. What is T? So by applying this one is FBD. Step 1. Step 2 is equations of motions again. So because we have this FBD, we consider only on this track A. So we consider the sum of F x is equal to M AX positive to the leftward. So substitute whatever the data is jotted down on this free body diagram. 160T minus this T is equal to 3600 divided by 9.81 mass of this track A multiply with EX. And we know that from the previous step, AX is equal to A is equal to 0.221 T. So we can directly substitute in this equation as well. So 160T minus T is equal to 3600 divided by 9.81 multiply with 0.221 T. And when T is equal to 2 seconds, 160 multiply with 2 seconds minus T, capital letter, to represent on the also called the coupling force T, is equal to 3600 divided by 9.81 multiply with 0.221 where T is equal to 2 seconds. So we only have one unknown, which is T. Then we can directly solve this one. If you solve this one, we can get the answer for this T. So T is equal to 157.8 Newton. You got the answer for this coupling force T. So we can also try to find out what is find the horizontal force acting between cut B and cut C. You can try to do it at home at your own. Also, when you at any time you're free, then you can try to do this. Let's say in this one, if you want to solve this one, of course you need to draw the free body diagram of a cut B. Draw the free body diagram of this cut B, and identifying all of the forces which act on cut B, and then applying the same step of applying this equation of motion as well for this cut B. You got the answer for this. What is the horizontal force acting between cut B and cut C? So that's it for this lecture 7. We're gonna continue on lecture 8A. Is there any question before we continue with this lecture 8? Lecture 8 part 1 Ada soalan tak? So tomorrow class between 2 to 4 we gonna do it physically inshallah. Tak ada soalan? Tadi kita sambung lecture 8A part 1. So just a brief review on lecture 7. This is an important note. The application of force, mass, and also accelerations. So we deal with this kind of what so-called problems. We can apply the appropriate method of solutions, whether you need to apply the rectangular XY coordinate systems, or you need to apply the normal tangent coordinate system, or you can apply the radial transverse coordinate system, or R dash theta method. So this depends on the question itself. Let's say we have this kind of situations, especially for this figure on the left hand side. We have this box or block which is located on this inclined plane, and which is acted upon by the external forces of multiple external forces of F1, F2 up to Fn. And in this case, of course, the initial step in solving this problem is always draw the free body diagram, or always draw the kinetic diagram, always draw the what's called kinematic diagram. So kalau kinetic diagram tu maknanya we need to consider all of the forces yang terlibat lah. As you can see here. Kalau kinematic tu dia lebih kepada velocity, accelerations, displacement, position, all of that. Itu adalah kinematic diagram lah. Dia tak ada pertimbangan untuk dia punya forces yang terlibat. So we can apply this, let's say, rectangular XY coordinate system. So sum of F X is equal to MAX. MX double dot adalah sama dengan X double dot. So in this case, X double dot, this one is equivalent with AX. Y double dot is equivalent with AY. AY. So we can write down the equation of sum of Fx is equal to MA. Let's say this one is sum of F X is equal to MAX. And for this one, sum of Fy is equal to MAY. So maknanya AY is equal to Y double dot ataupun V dot Y. V dot Y. Kita boleh nyatakan dia sebagai V dot Y. And kalau ianya berkait rapat dengan this application of normal tangent coordinate systems, then we can apply the sum of F tangent is equal to M A tangent for this one, and sum of F normal is equal to M A normal. Dan A normal tu dia sama juga dengan this R omega square, ataupun A normal is equivalent with this V square divided by R ataupun V square divided by rho. So we can apply both of this. Which one is more relevant based on the problem which is given in. Kalau ianya melibatkan this radial transverse coordinate system, then we can apply this equation of F theta which is equal to M multiply with R alpha plus 2 R dot omega. So kena rujuk balik lah. We have to refer back to the previous what's so called chapter 2, when you learn about this radial transverse coordinate systems. Here is the equation for this radial transverse R theta. Radial transverse. So theta ni adalah transverse lah. Theta ni adalah transverse. R ni adalah theta transverse, R adalah radial. Radial transverse coordinate system. So theta ataupun A theta is equal to R alpha plus 2 R dot theta dot ataupun 2 R dot omega. Pun boleh juga Manakala this A theta adalah A theta is equal to R double dot R double dot minus R omega square for this A theta pula AR radial AR silap. So radial acceleration is equal to R double dot minus R omega square. R omega square. Itu sekiranya ia melibatkan this application of R theta coordinate system lah. And here is the forces to consider. We need to consider all of the forces which act on a physical body, or in this case a particle. Ada pelbagai external forces which need to be considered. Ini adalah dia punya free body diagram dia. Okay. So always draw the free body diagram at the initial stage and then followed by applying the appropriate equation of motions. Okay, new topic to discuss is concerned about the work and energy. We start with this basic concept of work itself. Is there any question before we continue with this? Class? Okay.
Okay.
So we continue with the works and basic introduction of work. So mathematically, work can be expressed by the following equation. So we can write down, or we can use both either one of these equation. W is equal to F times D times cos theta. 1, 2, 3. Parameter pertama, parameter kedua, parameter yang ketiga. With this theta. W represent on works. Similarly to this U, W capital letter ataupun U capital letter represent on works. You can use either one of these lah to represent on works itself. Work can be symbolized as W capital letter ataupun U capital letter. So W is equal to F B cos theta. Similarly to this one, U is equal to F times B times cos theta. So F adalah cos. Force act upon an object. D adalah represent on displacement. Anjakan D, anjakan sesuatu jasad yang bergerak daripada satu kedudukan kepada kedudukan yang lain. Kedudukan awal hingga kedudukan akhir yang kita pertimbangkan at this instant. So D adalah displacement. Of course, bila displacement dia melibatkan jarak lah, distance. And the one is theta. Theta is the angle, angle between force and displacement. Displacement, tak nampak pula displacement. Padam. Force and displacement. So angle between the force and displacement. So mana dia ada 3 parameter yang perlu dipertimbangkan when we deal with this what so called work. Work is done when a force act upon an object to cause it to displacement. Suatu tindakan daya yang dikenakan ke atas suatu jasad sehingga menyebabkan berlakunya anjakan ataupun pergerakan suatu jasad tersebut. Daripada kedudukan 1 kepada kedudukan 2, daripada initial to final position. Itu adalah works. So maknanya dia perlu memenuhi beberapa kriteria ataupun kategori which is stated here. The parameter ataupun quantity which need to be considered is force, and then perlu ada displacement, and one is the angle between force vector and also the displacement vector. Again, if there is no angle between force vector and also displacement vector, then no works on that directions. So we continue with this what so called the introduction of work itself. So when we deal with this kind of situations, there are 3 scenarios which represent on the application of work. The first scenario is, look at these illustrations, they are the red arrow which represent on force vector and also displacement vector. Dan scenario B adalah scenario A, scenario B dan juga scenario C. So there are 3 scenario all together. So maknanya dia any motions, displacement of the object or particle in this case, maka pergerakan tersebut sama ada ianya akan dikategorikan sebagai berada pada kedudukan scenario A, scenario B ataupun scenario C. So let's have a look on this first scenario, which is scenario A. A force act rightward on an object as it is displaced rightward. In such an instance, the force vector and displacement vector are in the same direction. Force vector, displacement vector berada pada direction yang sama. Force, which is symbolized as F, displacement is symbolized as D. So kedua-duanya berada pada arah yang sama. Dia selari. So in this case, the angle between F and D is equal to 0. So tak ada sudut dah, sudut antara force vector and also displacement vector. So kita akan lihat nanti dia punya contoh-contoh yang berkaitan. Let me illustrate as well. So what is scenario A? A force acts rightward upon an object as it displays rightward. Let me illustrate for this scenario A. So we have a crane which is located on this surface. A force act, the force vector are in the same directions as the displacement vector. Force act rightward upon an object as it displays rightward. So kita ada block, this kind of block ataupun crane. Bila force act rightwards, so dia akan displace rightward as well. So let's say this one is considered as the initial positions and this here is the final position. So if you look at this, so it will displace to the rightward at the distance of D. So force adalah to the rightward as well. So maknanya dia, if you look at this one, the force vector F and also this displacement vector D are in the same directions. F dan juga D. F dan juga D. Then you can use the equation of U is equal to F times D times cos theta. Is there any angle between force vector and also displacement vector? So no angle between force vector and also displacement vector, which in this case theta is equal to 0 degree. So kalau let's say F is equal to 100 Newton. Okay, 100 Newton. And D is equal to 5 meter. What is the work done? So U is equal to 100 multiplied with 5 multiplied with cos, where in this case theta is equal to 0 degree. Because force vector and also displacement vector are in the same direction. F dan juga D. So sudut dia adalah kosong. Then you can get the answer of U is equal to 5 times 5, 5 kali 5, 200. 100 and this one, sorry for this one. 100 multiplied with 5, you got the answer for this U is equal to 500 Newton. Sorry. U is equal to 500 Newton. 5 kali 100 F dia adalah 100, D dia adalah 5 meter pergerakan sword pergerakan sword. Jadi daripada situ we can get the answer for this work of external force of F. So that is the first scenario. Force vector, displacement vector, F and also D are in the same direction. Let's have a look at this scenario B. Scenario B, a force acts leftward upon an object which is displaced rightward. In such an instant, the force vector and displacement vector are in the opposite direction. Thus, the angle between F and D is equal to 180 degree. So we look at these illustrations. F represent on the force vector, which is directed to the leftward, and D represent on the displacement vector, which is directed to the rightward. So, bila satu ke kanan, satu lagi ke kiri, maka dia akan membentuk sudut sebanyak 180 darjah. Macam ni lah. Sebenarnya. Here is D. And another one is F, which is directed to the leftward. D directed to the rightward. So, ni akan membentuk sudut 180 degree. Okay, 180 degree. Situasi yang sama. Let's say we have this grid. Yang kita pertimbangkan, let's say for this scenario B. Scenario B. Scenario B tu lebih kepada frictional force sebenarnya. We have a crate like simply like this, a crate or box which is located on this surface. Dia ada frictional force of this one is F. Fr. So Fr represent on the frictional force. So the frictional force is directed in the opposite direction of the external force of F, which is directed to the rightward. Kalau frictional force, maknanya dia berlawanan arah dengan pergerakan. Let's say this crate move to the rightward. It's displaced to the rightward at D is equal to 5 meter. To the rightward. And D is equal to 5 meter, and Fr is the frictional force. Let's say the frictional force Fr is equal to 500 Newton. Contoh 500 Newton. So if you look at this one, the displacement vector and also the force vector are in the opposite direction. Kan? D to the left, to the rightward, Fr to the leftward. So dia akan membentuk sudut of which is equal to 180 degree. Ini adalah D, ini adalah F, ini adalah theta. And therefore, if you look at this one, we can find out what is the work of frictional force. U is equal to F, Fr, F subscript R, kalikan dengan this D, kalikan dengan cos theta. Where in this case, theta is equal to 180. So Fr adalah 500 multiply with 5 meter cos 180 degree. So if you solve this problem, you can get the answer for this. U is equal to minus 500 Newton, because cos 180 degree is equal to minus 1. Kalau cos 0 degree is equal to 1. You can use your calculator, try to cos kosong berapa, kan? Cos kosong bersamaan dengan 1. Cos 180 sama dengan negatif 1. So, you can get this negative, sorry, this one is not Newton. Ni pun salah ni. U bukan 500 Newton. Newton meter. Sorry for that. Newton meter. Unit dia adalah Newton meter. This one is Newton meter. So 1 Newton meter is equal to 1 joule, 1 J. So you can write down the equation, the answer for this U is equal to minus 500 J. Capital letter of J, joule. Satu joule sama dengan 1 Newton meter. You can use either one of these what so-called unit for represent on works. That is the scenario B. Scenario C. Let's have a look on this scenario C. A force acts upward on an object as it is displaced rightward. In such an instance, the force vector and displacement vector are at right angle to each other. Thus, the angle between F and D is equal to 90 degrees. So in this case, for the scenario C, no works done. A force act upward. Macam ni. Force act upward based on this statement. As it displays rightward and at the same time, it displays rightward. This statement kan. Daya dia ke atas tapi dia punya displacement dia to the rightward, ke kanan. Seperti itu. So ianya akan membentuk sudut. In such an instant, the force vector and displacement vector are at right angle to each other. Which means that we have this F and also we have D at right angle to each other. Jadi akan membentuk sudut sebanyak 90 darjah, 90 degree. Thus, the angle between F and D is equal to 90 degree. Okay. So if it's happened, no work done because cos 90 degree is equal to 0. Okay. Cos 90 darjah sama dengan kosong. So if kosong, no work done. Even though displacement berlaku dan juga ada tindakan daya, tapi ianya membentuk sudut sebanyak 90 darjah in term of displacement vector dan juga force vector. Right? So no work done. So that is for the scenario C lah. Let's continue with this example. Example 1. A 100 Newton force applied to move 15 kilogram object a horizontal distance of 5 meter at constant speed. So maknanya basic equation yang perlu kamu ingat betul-betul adalah this one is actually basic equation for the constant forces. So U is equal to F kalikan dengan D kalikan dengan cos theta. In this case, F is equal to 100 Newton. D is equal to 5 meter. So F adalah 100, D adalah 5. Kan? What is the work done? What is the work done? So makna dia, based on these equations, the basic equation of above, U is equal to F, dia adalah 100 Newton. UFD. D dia adalah 5 meter. Cos theta in this case Oh, 0 degree. Tak ada sudut. Because both of that, in terms of force vector and also the displacement vector are to the rightward, which is 100 Newton. D is equal to 5 meter. So if you look at these questions, when you solve this one, we can get this U is equal to kalikan dengan 5 kalikan dengan cos 0 degree. And therefore, U is equal to 500 Newton meter. Sorry. U is equal to 100 times 5 times cos theta, which is theta is equal to 0 degree. Then you've got the answer for this. U is equal to 500 Newton meter. Okay. Okay, that is the first one. Let's continue to the next. Saya tambah surat. Okay, let's continue this second one. A 200 Newton force applied at an angle of 30 degrees to move 15 kilogram object a horizontal distance of 5 meters at constant speed. Okay. So here is the FVD 200 30 degree a 200 Newton force applied at an angle of 30 degrees to move 15 kilogram object horizontal distance of 5 meters at constant speed. So it's moved to the rightward and the distance of D, which is equal to 5 meters. So what is the work done? What is the work done? What is the work done? So U is equal to F times D cos theta, right? Is U is equal to F D cos theta. So in this case, U is equal to F adalah 200, D dia adalah 5 meter, cos theta in this case is equal to 30 degree. Okay. Jawapan dia adalah 866 Newton meter So U is equal to 866 Newton meter ataupun 866 Joule. So maknanya dia you can use any one of these lah to represent on the work done. Is there any question before we continue with the okay, I think this is the last one, example 3. Okay, example 3, the third one, the second one. The third one is here. An upward force applied to move 20 kilogram object to a height of 5 meter at constant speed. Okay? At constant speed. So the method of solution is here actually for this figure 3. Figure 3, this one. So here's the method of solutions. So W is equal to FD cos theta. Ataupun U is equal to FD cos theta. You can use any one of these notation ataupun symbol for the works itself. W is equal to FD cos theta, where F is equal to mg in this case. So F is equal to mg, which is equal to mass kalikan dengan coefficients, coefficient gravitational accelerations of g. So that's why when you look at this equation, ni adalah F. 20 kali 9.81. 20 adalah mass of this crane. 981 adalah dia punya gravitational acceleration. Gravitational acceleration which is equal to 9.81. Kalikan dengan distance of 5 meter, the distance. And also the cos, sorry, W is equal to FD cos theta, which is equal to 20, represent all this mass. 9.81 is gravitational accelerations. 5 represent all the height of 5 meter, the distance. And also cos theta, in this case cos theta is equal to 0. Sorry. Cos kosong, betul lah. Cos kosong because the force vector dan juga displacement vector are in the same direction, upward. So from this we can get the answer for this W ataupun U, capital letter of U to represent all works, is equal to 9H1 Newton meter. 9H1 Newton meter. I think that's it for today. Any questions to ask? Class?
No, sir. No, sir.
Okay. Tomorrow we gonna do it our class physically at where is the location? Kelas kat mana besok? Tengok balik jadual. Library if I'm not mistaken. Tomorrow class will be offline, offline lah. Physical. You need to check back the schedule for today and also tomorrow. Tomorrow class will be physical class. If there is no question, then we meet again. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Sama.
Thank you, sir.